This is chapter 27, example 2. This is a different type of example than the previous example. This is a state machine that models a shift register. So it models a 2-bit shift register. So these are classic problems. They can be very simple, which means they're very instructive, particularly when you're first doing them. They can get complicated. This really isn't one of the complicated ones. And it's an interesting thing. You got to see it once. You'll probably hopefully agree that it's not too bad. They're very straightforward. With all problems, the place to start on this thing is with the black box diagram. So I'm reading through this and I see it's a 2-bit shift register. And so the output of this circuit is essentially those 2 bits, and we'll call it Q. This is also, it's a shift register, certainly it has a clock in it. We have a reset input. Reset essentially put the flip-flop back into the 00 state, and it states that this is asynchronous, so we'll handle that. And in the state diagram, we also have a hold input. I think I'm just going to call it H, and we've got a D input. Despite what the problem says, I'm going to call that D. It's going to clean up the state diagram. Hold, D, reset. I think I'm done with the black box diagram. It's a shift register. It's a 2-bit shift register. Because there's 2 bits, there's 4 possible states. It's always the simplest thing to do to simply draw those states. So here's states, and I'll just go ahead and label them. These are the 4 possible states associated with 2 bits, 2 squared, the 4, here they are. So we need to start filling in these inputs here. Once again, the many ways to start in this, I like starting the easiest one. They all have a hold. The next thing here is we need to consider the D input. Actually, before we do that, let's put in the asynchronous input. Asynchronous input is a transition that comes out of nowhere and goes into a state. And so once we do that, we can call that reset done before we forget. Now the issue here is what happens when I get a D, or essentially I get a D or a D bar. So D equals 1 or D equals 0. So we'll start somewhere, a simple one, and it shifts right. And so if I'm in this state and I get a D, I go to this 1, 0 state. So that D represents a 1. There's the 1 in that state. And if I'm in this state, it's still shifting right, and I get a D, it goes into the 1, 1 state. If I'm in this state and I get a D bar, it goes into the 0, 1 state. If I'm in this state and get a D bar, it goes into back to the 0, 0 state. Remember, D bar is 0, it's feeding into 0 on this left side. It's a really good start. Now the issue here, it's not complete. Now technically speaking, I have 2 inputs, H and D, hold and the D input per state, which means I need 4 transitions leaving each one of these bubbles. And so we'll go back and look at this again. This transition here only has 2 transitions leaving it, and so what it's missing is the D bar transition. So if I get a D bar, which is a 0, it stays in the state. So the issue, what we do here is put a D bar on that. The fact that it's H or D bar is actually 3 different conditions. The D down here is the 4th condition. So those are the 4 transitions leaving that state. So in this state, I have an H leaving it. The hold keeps me in that state, but if I get a 0 in the state, which is a D bar, I'm going to go to this state. I have various arrows leaving the state. I need 4 of them, but I don't have 4. So what it turns out here is that these D's and the D bars are actually not right. It's actually D bar and H not. And this is a fine point here. Essentially, the only way it can change states is when the hold is not asserted. So all of these, before I forget, need a H bar in it. So there, once again, I check how many arrows are leaving these states. This is 1, 2, doesn't matter what D is in these. 1, 2, 3, 4, and I'm going to go ahead and call that state done. And it looks good in this state here. This is similar to a previous state where a D bar gets me out of the state, but of course it needs an H bar in there, and very similar to that 0, 0 state, another thing that keeps me in the state is when I get a D, which is a 1. So if I get a D or a hold, it stays in this 1, 1 state. And this last state here, I have a D bar leaving it, which is a D bar, H bar. I need to get that correct. But it's missing a D, so if I get a D in this state, it's going to transition to this 1, 0 state, where that D being the new 1 right there. I am done with this problem. State diagram, there's no blocks in it. I could actually use a table to set this up. The table makes no sense. It's just impossible to read. Take one final look at this, make sure I didn't forget anything here, and I think I will call this done. But the interesting thing here is when I'm in these two 0, 0, the 0, 1 and 1, 0 state, the hold is simple. It's not complex like these states. And in these states, it's a little bit different because both state variables are the same. In these two states here, the state variables are different.